In this video, I'll be explaining how integration techniques can help us solve infinite series problems. Don't worry, I'll keep it simple and fun, even though we're dealing with infinite math. Let's start with part A. So, integration is a mathematical process that helps us find the total or area under a curve. It's basically the opposite of differentiation. If differentiation tells us the rate of change, integration tells us the accumulated change. For example, if we know the velocity of a car over time, integrating that gives us the total distance traveled. Now, what about infinite series? An infinite series is the sum of endless sequence of numbers. For example, 1 plus 1 over 2 plus 1 over 4 plus 1 over 8, and so on. Even though it goes on forever, the sum actually approaches to a certain value. In this case, 2. Let me explain what infinite series looks like using a simple picture example. 1. That's the first term of the series. Now we add the second term, 1 over 2, which is half of the square. Our shaded area is increasing, but is still not full. Now if we keep adding, visually we can see all the pieces together fill the space equal to 2. So infinite series are basically a way of expressing functions or values as an endless sum or smaller terms. Now, let me demonstrate two techniques of integration and explain how infinite series can appear in integration problems. So let's look at the first technique, use substitution. Use substitution is used when we notice a function inside another function, kind of like a function sandwich. Let's take a simple example. Integration 2x cos x power 2 dx. So we set u equals x squared, which means du equals 2x dx. Then the integral becomes integration cos u du. So if we integrate that, we will get sine u plus c. Now, substitute back u equals x squared. So the answer is sine x squared plus c. And we're done. This method makes complicated integrals simpler by changing variables. So for technique 2, the next method is integration by parts. It's used when we're dealing with two product of two functions like x(ex) or x sine x. The formula is integration u dv equals to uv minus integration v du. Let's use the example. Integration x e power x dx. We let u equals x and dv equals e power x dx. When du equals dx and v equals e power x. So if you apply the formula, it becomes integration x e power x dx equals e power x bracket x minus 1 plus c. That's the answer. Integration by parts is like teamwork. One part gets differentiated, the other gets integrated. So sometimes we face functions that can be integrated normally. For example, integration of e power x power 2 dx. This has no simple formula, but we can expand e power x power 2 as an infinite series. So the formula of this infinite series is shown. Now integrate it term by term. It becomes x plus x power 3 over 3 plus x power 5 over 10 and so on. And that gives us an infinite series result instead of a single answer. That's how infinite series helps us when normal integration doesn't work. Now, many important functions can actually be written as infinite series. Here are some examples. These are called Maclaurin series, and they help us integrate or differentiate complex functions using just simple powers of x. Now let's take example we did using u substitution. Integration 2x cos x power 2 dx. The series of cos x power 2 is 1 minus x power 4 over 2 factorial plus x power 8 over 4 factorial and so on. So if you integrate, it becomes integration 2x bracket 1 minus x power 4 over 2 factorial plus x power 8 over 4 factorial and so on dx. So after we integrate it, we get x power 2 minus x power 6 over 3 factorial plus x power 10 over 5 factorial. That's actually the same as the series for sine x squared, which we found earlier using normal integration. So both methods give us the same result, proving that integration and series method are connected. So in real life, integration and infinite series show up a lot in engineering. For example, in mechanical engineering, we use series and integration to analyze vibrations, heat transfer, or fluid flow, systems that often can be solved exactly. So, infinite series and integration work together to model real-world behavior. Understanding integration techniques helps us handle problems that don't have exact answers. It allows us to make approximations, build models, and solve complex systems, things that engineers do all the time. So learning this isn't just about passing exams. It's about building problem-solving skills that are useful in real engineering work. That's the end of my presentation on techniques of integration and infinite series. We covered what integration on infinite series are, learned two techniques, linked them through series, and saw where they are used in real life. Thanks for watching.